in the Cornish tin and copper mining industry leads to advancements in metallurgical science. Hello, I'm travelling to the tin and copper mines. Today I intend to produce content on the process of smelting in Cornwall and how the Cornish copper and tin mining industry contributed to the advancements in metallurgical technology and science, specifically bronze. Let's get to site. I'm on site at Wheel Edwards. The process of smelting and the development advancements in metallurgical technology, specifically bronze. Let us get scientific. Here is where copper and tin sit on a periodic table. Here I have highlighted the element copper in the red square. The element tin is highlighted here with a red square as well. In this graphic I have extracted the two elements from the table in order to focus in on them in more detail. Copper is identified by element symbol Cu. It has an atomic number of 29 and an atomic mass of 63.546. Copper is described as a transition metal. Tin is identified by element symbol Sn. It has an atomic number of 50 and an atomic mass of 118.71. Tin is described as a basic metal. Commodity pricing. The current value of copper is circa £12,760 per metric tonne. Tin is currently valued at around £39,000 and has peaked at over £40,000 per metric tonne. As an engineer, in order to assimilate by comparison, I like to know the mass of various materials. Per cubic metre, copper is 8,930 kilograms, whilst tin is 7,265 kilograms, a difference of over 1.5 tonnes per cubic metre. Therefore, copper is significantly heavier than tin. As a benchmark, just for comparison purposes, water is 1,000 kilograms or 1 metric tonne per cubic metre. The periodic table is a chart that scientists use to organise all known chemical elements in a logical way. It is one of the most important tools in chemistry because it reveals patterns in how elements behave. Okay, let's refer to smelting. I just wanted to reflect upon the process of smelting. When it comes to mining and the extraction of valuable minerals from earth, smelting is the end process in a long line of complicated operations. In simplistic terms, smelting is the process of separating the desired metalliferous elements from the crushed rock ore by subjecting the granules to very high temperatures until molten. Once the molten metal has achieved the melting point, it is poured into a mould where it is left to solidify and take on the form of the mould in one way not too dissimilar to the casting process. When released or extracted from the mould, the block or shape is then termed an ingot. Here are a few photographs depicting various ingots from some of the more famous historic smelting companies in the Cornish region. Typically, each having their own individual and unique identification markings known as smelter's house marks, produced by a handheld die pressed into the semi-molten metal, leaving a raised relief feature. During the smelting process, specific additives can be used to refine and purify the molten metal to reduce or ideally eliminate any impurities within the mix. Silica or quartz is used in copper smelting to remove iron oxide impurities, for example. In more detail, the process involves placing the granulated ore into a ceramic vessel called a crucible, which is loaded into a furnace or hearth and heated to a known temperature in a controlled manner. This is termed a crucible furnace. The temperature elevation depends on the element being extracted, also noting that overheating at this stage can be detrimental to the operation. Here is a graphic depicting some common elements and their melting points. Tin has a melting point of 232 degrees C, whilst copper has a significantly higher melting point, which is around 1085 degrees C. Here I have transposed my tabular data into graphical format. Tin has one of the lowest melting points of common metals, whilst copper has a melting point of some 4.6 times greater than that of tin. It requires a significant higher amount of energy to smelt. This is one reason why the Cornish copper industry started to ship the ore granules to South Wales, where the commodity coal was mined in abundance and used to fuel the smelting furnaces. The returning vessels were back-loaded with coal, which was used to fuel or fire the steam boilers that energised the pumping and winding engines. The low melting point of tin gives it great advantages and is an extremely useful and critical global commodity. The higher melting point of copper gives this element different characteristic properties and advantages, and is also a critical global commodity for the manufacturing industries. It is safe to say that the world would be a different place without either of these elements. Due to increasing global demand, and as the years roll by, both are becoming more and more sought after, with an eventual risk of current resources becoming depleted. Just for comparison purposes, iron has a melting point of 1538 degrees C, whilst tungsten has a melting point of 3422 degrees C. And the main characteristic properties of tungsten is that of hardness, resilience to high temperature, and thermal shock. And uses include cutting tools, including rock drill tips used in mining operations. Here is a photograph depicting a tungsten insert in a typical rock drill tip, for example. Metallurgy is a science that has developed and advanced over the centuries. Today, metallurgy is an advanced science, a technology of extracting metal elements from their ores, refining and processing them into useful products. It involves studying the chemical, physical, and atomic properties of metals and alloys to improve strength, durability, corrosion resistance for applications in manufacturing, construction, and engineering. Key aspects of metallurgy include extractive metallurgy, which concentrates on extracting valuable metals from raw materials, minerals, and ores through methods like smelting, roasting, and leaching. Physical metallurgy focuses on the physical and mechanical properties of metals, including the microstructure, to optimize performance. Mechanical process metallurgy. This involves shaping and treating metals through methods such as castings, forging, rolling, welding, and heat treatment. Now, key processes. Ore dressing, which involves crushing, grinding, and separating ore from impurities. Smelting or refining, This involves using heat and chemical reducing agents to convert raw ores into pure metal. Alloying, combining metal with other elements to enhance properties, creating steel from iron, for example, or bronze from copper and tin. And heat treatment, which manipulates heat to change properties like hardness and toughness. My intention is to produce a vlog specifically on alloy steel going forwards. Metallurgy is vital for modern technology, impacting industries like aerospace, space, automotive and healthcare by enabling the creation of specialised alloys and metallic materials. This subject is vast and very fascinating. Interestingly and historically, it started to rapidly develop during the 1800s and became an integral scientific industry within the Cornish mining landscape, which helped fuel the Industrial Revolution. As mentioned in my previous video content, we are where we are today with metal technology thanks to the Cornish tin and copper mining industries, creating the foundations on which the technological material science has been built. For example, the advancement in bronze. The term bronze historically refers to a mix of copper and tin. However, modern day engineering uses various alloying elements to create specialized types of bronze. Here are the 9 most common types of bronze used today. Number 1, phosphor bronze or tin bronze, which is about 95% copper and 4.8% tin with about 0.2% phosphorus. And in some cases, lead can be used or added to the alloy for specific application properties. Many years ago when I was an apprentice, this was the most common type of bronze used in heavy engineering for rolling mills. And this is a classic bronze, copper and tin. Now, tin enhances corrosion resistance and phosphorus increases wear resistance, whilst lead provides a lubrication property, providing low friction, and typical applications for this would be ships' propellers and in fact heavy wear plates in steel rolling mills or steel rolling equipment. Number 2 is aluminium bronze, made with between 6 and 12% aluminium. This alloy is exceptionally strong and resilient to corrosion. It is the top choice for marine hardware and industrial pumps, where exposure to harsh chemicals or seawater environments is a factor. Number 3 is nickel aluminium bronze. By adding somewhere between 3.5 to 4.5% nickel to the aluminium copper mix, engineers create an even stronger material. It is specifically used for heavy-duty marine applications or big valves and also ship propulsion systems because of its resilience to biofouling. Number 4 is silicon bronze, containing about 96% copper and 6% silicon. This type of bronze is known for its weldability and smooth finish. It is frequently used for architectural finishes, artistic sculptures, marine fasteners, and certain hydraulic applications. And it exhibits high tensile strength, greater than that of pure copper. Number 5 is manganese bronze, 62% copper, 25% zinc, 5% aluminium, and up to 5% manganese and 3% iron. Now, typically, this is a high strength brass as it contains a significant amount of zinc, up to 25%. It is valued for its extreme toughness, and because of its resilience, it's found commonly in heavy gears, landing gear equipment and components for aircraft. Number 6 is bearing bronze or leaded bronze. The name suggests this alloy is designed for low friction applications like bearings, sleeves, bushers. It often contains somewhere between 6 and 8% lead, which acts as a built-in lubricant, allowing it to perform well even if external lubrication systems momentarily fail. Number 7 is bismuth bronze. This is a modern eco-friendly alternative to leaded bronze by replacing the lead with up to 6% bismuth, and it maintains excellent machinability and corrosion resistance without the toxicity of lead, making it suitable for drinking water systems. Number 8 is copper nickel or cupronickel, consisting of 70 to 90% copper or 30 to 10% nickel. This alloy is famous for its silver-like appearance and superior resistance to salt water. Beyond ship's hulls, it is widely used in desalination plants, for example, and also coinage. And the last one, number 9, is beryllium bronze. This is the strongest and hardest of all copper-based alloys. It is non-magnetic and does not spark when struck, making it critical for tools used in explosive environments, as well as high-precision aerospace components. Just for comparison purposes, there are over 3,500 grades of steel. Steel is an alloy. Now, tin and copper are valuable commodities. In today's prices, tin is around £40,000 per tonne and copper is about £10,500 per tonne. I trust that you've found this of interest and hopefully we can connect in my next content. I hope you're still with me. If you are, thank you. Also, I'd like to thank you for viewing, liking, subscribing, sharing and leaving comments in my last video. Really appreciate that. Until next time, bye until then. So I'm leaving this amazing historical site, and I do believe that the Cornish tin and copper mining most certainly contributed to the advancement in metallurgical science.